about the gas. With gases.
Ladies and gentlemen, thank you very much for giving me the opportunity to talk to you about something that, about a word that has been used very seldom here the past two days, about salt. It's funny, this world is divided into several sections. You are producing holes, and we are not worried about what comes out of it. We are taking the brine, we are making salt out of it, we are delivering it to caustic chlorine people. The caustic chlorine people have no idea about salt, and salt people have no idea about caustic chlorine as a rule. Anyhow, why am I here and why I would like to talk to you about SEISMOSAL? We are producing salt. We are also doing some explorations of underground salt deposits. This one is in Namibia. It's a small deposit. It's only about 50 kilometers long, 20 kilometers wide, and 15 to 20 meters deep. The exploration takes long, several days for the core drilling, even though it is just 15, 20, 25 meters. So when these are the core samples. 15 meters is the last one. The first one is some sand, and there is some mud in between. So when we, in March 2016, were approached by a company called ATS, that they have an electro-seismic method for exploring or for allocation of the geological formations that are suitable for water production. And then they said, well, they are really able to find out the difference between water and salt water, and they really can determine whether there is an oil underground, and that they even discovered gold. They said gold. Our logo is turning salt into gold. So if they can discover gold, why shouldn't they be able to determine a salt deposit? So I said yes. This is how they do it. They take a sledgehammer, a plate, steel plate, put it on the ground, hits the ground, and then they record the electromagnetic response. Why the seismic wave gives electromagnetic response? This is the explanation. They say, I haven't seen it, but that's what they say, if a grain of sand or something similar is in liquid, and the liquid contains some ions, and water always contains some ions, then these ions are more concentrated on the surface of this grain than a little bit further apart. And when the seismic wave hits this grain, then the ions move. And this movement produces electromagnetic waves. So if we have a seismic source, if we have a seismic source here, and the seismic wave hits some kind of interface in the geological formations below, and it is wet, or there is some groundwater, some moisture is there, then electromagnetic wave is created and can be recorded using an antenna. This antenna consists just of two metal rods driven into the ground about half a meter deep and about 2 meters apart, connected with a wire and a recorder. The other response is an electro-telluric response, and this is created by a head wave. This is the head wave that drives along two stratas, about a strata of higher concentration and lower concentration of some dissolved salts. This electro-telluric response forms an electric field, or again an electromagnetic field, which is also recorded. The physical principles of the electro-tellurics, there are several layers in the ground, and they are electrically connected, and by the action of the sun, the currents are created and flow from the poles to the equator, and so on and so on. But I think that this is beside the point. What is required for the electroseismic mapping? The equipment is very simple. It's a plate, a steel plate, about 2.5, about 1 inch thick and 1 foot in diameter. It's recording equipment, sledgehammer, the 2 electrodes, and a set of cables connecting the electrodes with the recorders. Now I was, of course, very enthusiastic about it, because I thought if it is possible to determine a salt layer underground with such simple equipment, then it may have a potential. We have then went out and asked people, well, you have salt and you know where you have salt, could we try it there? And we have a good relationship with the Swiss salt works, and we contacted them and they said, yes, you can do it. And we have determined this place, this field here, as a suitable field for the trial. This is the salt works. My previous company, Echevis, built the salt work when I started with them in 1975, and I learned how to build salt plants. This was one of them. So it's a very well-known plant to me. These are the storage of the salt there. There are about 250,000 tons of salt there, and here is the field. It's about 600 meters long, 200 meters across. There are 2 caverns there in operation, and we said, all right, we will do every 50 meters here, then whatever we can do here in the field, and we will do about every 50, 70 meters here. We have done it in June, and it was about 35 degrees centigrade. You can see the salt deposits here in the back. So we have said no personal protection except for a good sun cream. What we did know about the salt deposit there. Swiss Saltworks gave us very kindly information about the salt layers there. We got a contour map. We got a bottom of salt layer contour map, the top and bottom. We got drilling logs at a couple of points within this field. We got salt layer profile interpolated from 8 exploratory drillings by a company called Hauber. We got locations of electrical cables, brine piping, water piping, and the existing brine caverns. So we knew that the salt is there. Of course, we know that the salt has been produced there by solution mining since about 170, 180 years, I think. So there's a lot of knowledge about it, so it was an ideal place to try this new method and to see what is the correspondence between what is known and what we are measuring. Within a very short time, about a week, we got the report from ACS, 99 pages, with a theoretical part, with 17 quality control evaluations, with 3 GPS location determination, precise determination of the body of the ground that was investigated to the depth of about 300 meters, and 24 electro-seismic and electro-telluric data renderings, interpolations, or not interpolations, no, interpretations. Salt layer profile by Hauber was incorporated in the 3D model. Detailed description and interpretation of the 24 data sets and 22 scientific references. These are 3 of the scientific references. The rest is in the paper that you have a copy of. Now, this is the electro-telluric salt layer determination that actually shows the salt layer with a precision of plus minus 1 meter. Now let me comment on it. Here we have the surface 295 meters above sea level. We have here some layers showing differential conductivity. Why? It's a field. In the field you have fertilizer. The fertilizer gets into the ground, into the soil, and changes its concentration. The ground is wet, so you have layers of changing conductivity. Then you have a layer of about 100 meters, 520 meters of permeable overlying formulations. It's mainly sand and gravel and some dolomite and so on and so on. The River Rhine flows about 600 meters away, and this layer is of course full of groundwater, sweet, normal, sweet drinking groundwater quality, excellent quality. Then we have this layer that shows the top of the salt. Now what you can see here is the profile that we got from the salt works, from the Swiss salt works. And it has salt here and the cup rock. And this electro-telluric response is just above the cup rock. Then we have the bottom and another electro-telluric response here, here, and here. Now I would like to show you the model. I can turn it around and with a little bit more, and there you can see the void between the electro-telluric top and the salt. Then a little bit more, take a look at it from the top, take a look at it from the bottom, I mean up to this electro-telluric response, down and round. The bottom, the formations below the salt. This is the fertilizer in the field above, and what you can see is that you see nothing really in the layer above and in the salt layer itself. The salt layer is not giving any response at all. Right. Okay. Now there is another. If you can show the view number 1. There is another view of the responses. This is this one. This shows geological formations that are permeable, that are porous, and that are groundwater carrying. And here you can see that whatever is there above this cup rock is just full of groundwater. Okay, we can also see some porous layers here where the cavities are, here for example, and here, but that's not clear enough. Okay, now I think that you might be interested in understanding why we think that it's possible to show with such very simple and fast method to determine the layer of salt with such an accuracy. Salt is dry. The rock salt is dry. There is no water. There is no response. There is no possibility for the current, for the electro-telluric current to flow. The cup rock is what is left from the salt that has been dissolved in the overlying groundwater. The salt contains calcium sulfate, salt dissolves, calcium sulfate remains, compacts, turns into hemihydrite, into anhydrite, and so on, and protects the salt from further dissolution. But the cup rock itself is porous, and therefore it is wet. And the salt still diffuses through this wet layer of the cup rock to the overlying formations, which only contain drinking water. So there is a very distinct layer of changing conductivity. And when there is such layer, we believe that we can apply this method, this electro-seismic method, for salt prospecting. So what are the conclusions? We needed 29 strokes to determine a salt layer over an area 200 by 600 meters. We had done it in 1 day. 100 strike points, that would be an area of, let's say, in a greater depth of, let's say, 1 kilometer by 1 kilometer, we can do in 3 days. The evaluation can be done within 1 week maximum. And it is accurate. We have seen that the accuracy of plus minus 1 meter is possible. We believe that the potential is there. We seek cases where this method could be applied on experimental development trial basis. We think that we can determine a top and bottom of an overhang of a diaperic formation. We think that we can even determine the existence of a cavity, because as long as it is full of brine or some other liquid, because of the very significant difference in seismic velocity in salt and brine. We think that we can determine also the sludge at the bottom of the cavity, because it is porous and it is full of liquid. And that's, I think, the purpose of my presentation here. If anyone would like to ask any questions, and if anyone would like to indicate to us a possible application for this method, we would be very, very grateful. So, ladies and gentlemen, thank you very much for your kind attention. And if you have salt or any problem with the salt, please come to us. We are turning salt into gold. Thank you.
My name is Abiel Smit, I work for NetMag. Can the method also distinguish between the various types of salt? You said you might be able to distinguish between fluid and salt, but are you also able to distinguish between the various types of salts in a salt layer which contains more than one type of salt?
Well, whether we can distinguish between various types of salt. Well, I would have thought that the bedded salt, and this one is a bedded salt, of course, in Switzerland, would give a different response than, for example, a very pure diaperic salt. But it does not seem to be the case. The dry salt simply does not give a response. Whether there would be some other, I would definitely expect Sapka salt, for example, and that is the first picture that I was showing you. That's a relatively young rock salt deposit, perhaps a million years old, that is still in the seawaters, still in the mother liquor. That would definitely give a different response. But rock salt, diaperic formation, or bedded formation, I'm a bit skeptical that this is possible, perhaps with much higher seismic wave power. This is sledgehammer, but if we have to go to greater depth, we can go up to 4 kilometers depth. But of course with a mechanical seismic wave generator, for example with a hydraulic rock breaker or something like that, then perhaps, and with much closer matrix, perhaps 10 by 10 meters or something like that, it might be possible. But the taste of cake is in eating.
Okay.
These are all the names of the ships from the very first.